Alright guys, welcome to this page of the notes. Now what we're going to do here is we're going to actually do one of these problems where you have been given a set of data. I'll go over that with you in a second. Also, on the coordinate plane, I have already entered units onto my coordinate plane. I'll go over those with you in a second just to save a little bit of time here on the video, but I'll show you what I did and how I did it. So let's just go ahead and jump right into this. First, we're going to graph our data set, and then we're going to go ahead, find our best fit line, and then use it to make a future prediction. So here we go. The table below shows the mean selling price for new privately owned single-family homes for 6 consecutive years. So that's what's in the data set. It gives you the year and then the price of the home, of course, in thousands, right? So year 0, 154.5 thousand, year 1, 166.4 thousand, and so on for 6 consecutive years, showing the price of a privately owned single-family home. Now, what we're going to do is we're going to go ahead and graph this data set. So I have a coordinate plane for you here, and here's what's going to happen. We're going to go ahead and graph the data, and then we're going to draw a best fit line, a line that I think best fits this data set and the correlation that this data set has. So here we go. Let me show you my graph. All I did was, of course, right down here on the x-axis, which is always the independent variable. Well, in this case, the independent variable is time, right? The year. The price of the homes doesn't determine the year. The year determines the price of the homes. So right down here on the y-axis is going to be the year. Let me switch to my pen, sorry. So right down here on the the y-axis, the x-axis, I have, this is years. And I just went right because my graph is 20 units across, and I only have to go from 0 to 5. 20 divided by 5, of course, would be 4. So every 4 units, I just put a year. Then I need to go, according to my data set, roughly my prices start above 130,000. They're all below 310,000. So I just made each unit $10,000. So 130, 120, I'm sorry, 130, 140, 150, 160, I marked 160. That way you can still read my units. I don't have them jammed in there so tight, but each one is $10,000. So 160, 170, 180, 190, 200, 210, 220, right? I'm just going by 10,000s. And of course, this is going to be the price of the home in thousands of dollars. So let me put that on here for you. This is price of those single-family privately owned homes. So now we go ahead and we are going to plot our data. Let me do these in red for you and do it in a mark big enough that we can see. So here we go. My very first one, I am looking at 0 and 154.5 thousand, 154.5. Now, because of the way that the units are set up, you're not going to be exact. Just get it as close as you can. I'm not going to go crazy when grading these on a quiz or a test, you know, that you're at, you know, maybe 155 instead of 154, right? Don't panic about that. So 0, and we're at 154, which is going to put me just a little bit below that 160 mark. I'm going to say maybe right about there is pretty good. Let's put my point in there. There's my red, my size, and awesome, and right about there. So there's my mark. My next one is at 1 year. 1 year, I'm at 166.4, so that's going to put me right about, let's see, 66. I need to be below 170, maybe right about there. There's going to be my point at 166,000. Year 2, I'm at 181, about 182,000. So let's see here. There's going to be 180. Yeah, let's go maybe right about there. Okay, cool. We'll put it right there. Year 3, I'm at 207,000. Well, there's 190. There's 200. It put me between 200 and 210, and that's in year 3. So let's see here. 300. There's 200, 210. So maybe right about there for year 3. Let's see, year 4, I'm at about, well, it's exactly 228.7. roughly 230,000. So let's find that one, year 4, 200. Let's see, there's 220, there's 230. I need to be a little bit below that, maybe right about there. And then year 5, we're at 273,000. All right, so 50, 60, 70. I need, as long as I'm between 270 and 280, 270 and 280, let's go right about there. And we'll call that my point right there. So let me go ahead and slide this up now that I pulled that information off of my data set. Now what we've done, right, is we have graphed the data that was given to me in a chart. Now on your graph, you may be able to see a little bit better than you can on mine that there is not a straight line that you're going to be able to draw that will go through all of those data points, right? There's no way to draw a straight line that goes through all of them. They actually kind of make a little bit of a curve, but I'm not drawing a curve. I need to draw a straight line. So how do I do that? Well, what you're going to do in the homework is you want to pick 2 points, just 2 of them, all right, that as best as you can, when you draw a line through those 2 points, right, you have about the same number of data points below your line as you have above your line. Let me show you a bad choice. If I were to pick my very first data point, year 0, and I were to pick my very last data point, year 5, and I drew a straight line through those, it should be the same on your guys' notes as well. You should be able to see it. If you were to draw a line through those, this point, this point, this point, and this point, all 4 of those points will be below the line. Well, that's not good, right? If everybody's below the line, you've kind of missed it, right? You want about the same number of points below as you have above. So if I just tweak it a little bit, maybe if I go year 1 and year 4, if I draw a line through those guys, it actually looks like what might happen is these 2 data points may be just below the line, and these 2 data points may be just slightly above the line. That's perfect, right? What I've done is now I've split that data set with the same number of points below my line as above, and that's about as good as you can do. Now somebody else may pick a different 2 points and have the same result. Same 2 above, same 2 below, and they use different data points. That's perfectly okay. There's a little bit of ambiguity here. You kind of get to make a choice. Now when it comes to a quiz or a test, I don't want choice, all right? I want everybody to get the same answer. So what I'll do for you on a test or a quiz is I'll do this. I'll let you know which 2 data points I want you to use so that we all get the same answer. On the homework, you get to pick. On the quiz or the test, I'll let you know. So here we go. We're all going to use the exact same ones. Let's go with the one I said, year 1, because I think that's going to work out really well. We're going to go with that first year, year 1, and we're going to go with year 4. Just because, as I pointed out a second ago, that's going to leave me with 2 data points below the line, just below it, and 2 data points above the line. So let me go back down and draw my best fit line, because what they ask you to do here, right, is draw a line of fit. That's you drawing your line of fit. So we're going to do it through point 1 and year 1 and year 4. All right, let me do this in red. Switch my line back so it's a little thinner. That way I don't cover everything up. And here we go as best I can. Let's see how this goes. I'm going to go right through here to this guy. Oh, I like it there. And back this way there. All right, that's not bad. Please make sure that you extend your lines all the way through the coordinate plane I've given you. Make sure you put arrows on either end. All right, here we go. As you can see, if you did the exact same thing I did, I now have 2 points that are just below the line. This point is just above. This point's up above it a little bit, but again, I've about as evenly as I can, I've split that data set. It's not going to be perfect. Your calculator will get it perfect, but we're just drawing a best fit line, as best as we can get. So I've answered that question right there. Draw a best fit line, and that is exactly what we've done. Now, the next part is write a prediction equation. So we want to go ahead and now write our prediction equation. Remember, we're going to use the point-slope form of a line, which means I need a point and I need a slope. Well, I have 2 points. I picked 2 points, year 1 and year 4. Those are the points we're going to use to find the slope. So let's do that first. Let me find my slope here. I'll do that in blue. All right, according to my data set, in year 4, the average price of a privately owned single family home was 228.7. Just check up there in the data set. So 228.7. That was in year 4. From that, I'm going to subtract the price of a privately owned single family home in year 1, which according to the data set says is 166.4. So 166.4. Sorry, I'm standing in front of it. There you go, 166.4. And that was in year 1, so minus 1. All right, here we go. If you go ahead and use your calculator, don't fat finger something on your calculator, you should get 62.3 in the top. 62.3 all over 3. Which means that as a fraction, go ahead and multiply top and bottom by 10. You wind up with 623 over 30. 623 over 30. 623 over 30. All right, now I need to write my prediction equation. I now have my slope. I only need to use one of the 2 points that you picked. I either use year 1 or use year 4. I'm going to go ahead and use year 1 because 1 is generally easier to do math with, and since I'm going to have to do some algebra in the equation, I might as well use a 1 instead of a 4. So here we go. Now that I have my slope, let me go ahead and erase this so that I have plenty of space. So I'm going to erase this stuff. I'm going to move my slope over to here. Again, it was 623 over 30. So here's my slope. M is equal to 623 over 30. And let's go ahead and start writing that prediction equation. Here we go. So it's going to be y minus, okay, so y minus my y value for year 1 is the price of this privately owned single family home, 166.4. 166.4. That's going to be equal to my slope, which is 623 over 30, multiplied by x minus my x value, which was year 1. Okay, what we need to do now is distribute the 623 over 30 through the parentheses. We'll add the 166.4 to the other side, and let's go ahead and see here what this is going to look like. I'll rewrite this one more time before I do it. So y is equal to I apologize, y minus 166.4. Y minus 166.4. 623 over 30x minus 623 over 30x. All right, we'll add the 166.4 to the other side, so we'll have 623 over 30 plus 166.4. Again, your calculator will go ahead, it'll do all of that for you. And I get this, I get y equals 623 over 30x, plus 4,369. 4,369 over 30. And if you write those as decimals, which you certainly can do, it would be 20.76x, 20.76x plus 145.6. All right, either of those are perfectly acceptable answers for our prediction equation. Again, just using the point slope equation of a line, distributing my slope and then adding my y value or subtracting your y value to the other side. So there's my prediction equation. Now this is the power of these best fit lines. We're now going to use it to predict the selling price of a new home in year 8. Keep in mind, remember that data table only went to year 6. So what we're doing is essentially predicting the future price of a privately owned single family home 8 years down the road, even though we're only in year 6. And you can begin to see the power of this. If you own a company, right? And you're trying to predict future sales or predict future profits, right? You look at what you've done in the past, come up with a prediction equation, much the same way that we have, and you could predict future sales or future profits or even future costs for that matter. So tons of power here when it comes to these prediction equations. All we're going to do is we're going to take my prediction equation, I'll use this one, and we're going to go ahead and plug the year 8, in for x. We'll solve for y. So let's go ahead and do that. I'll have y is equal to 20.76 multiplied by 8, I want year 8, plus 145.6. And what I get when I do that is y is equal to, I get 311.6. 311.6. Now remember, that is in thousands. Our prices were in thousands. So that I'm predicting in year 8 the price of a privately owned single family home would be $311,000, almost $312,000. Now, how accurate does your prediction appear to be? Well, I would say probably pretty accurate. Look at this. It appears that it is in an upward trend. And so it makes sense that if I were to go to year 6, year 7, and there in year 8, keep this graph going out, yeah, absolutely, that line is going to be up there above $310,000. So as far as how accurate do I think my prediction is, I think it's good. I think this is a really good prediction. I think we came up with a great equation. And of course, it's not going to be exact. We are making a prediction. My line didn't go through all of my points, so it's not perfect, but it's probably pretty dang close. Pretty dang close. All right. That takes care of this problem. Hopefully that makes sense. We'll do another one on the next page, so head on over and I'll meet you there.